rosemary and the thyme and the things.
Okay, I think we're ready. Yeah, we can start.
Okay. Okay, guys, I think we're going to get started. If anyone else trickles in, they trickle in, but.
Good?
Yep.
Okay. Hi, good afternoon, everyone. My name is Luke Doe. I'm a seismic engineer from Mason Industries. I've been with the company for over 25 years, doing mainly vibration isolation and seismic bracing controls for MEP systems. A little bit about the company, our headquarters in Long Island, New York, but we have a satellite office here in Southern California and Anaheim. We manufacture vibration control products, seismic bracing components, anything from building isolations to isolation to little panels on the wall. We do them all. But today, the purpose of this presentation, the main focus is going to be on seismic bracing of MEP systems, non-structural components. Okay. We're going to be focusing on the latest code cycle, California building code cycle that we're currently under. Starting January of this year, everything's going to be under the 2025 California building code. As far as seismic bracing for non-structural components, the requirements are pretty much the same for the last three building code cycles, 2019, 2022. To 2025 currently. The seismic bracing requirements are the same when it comes to a non-structural component. Very little bit, but for the most part, 99% of the time it's the same. So, non-structural components. When it comes to non-structural components damages in an earthquake, they account for up to 50% of all seismic earthquake-related damages over the years. 50%. So, for that reason, they have significant economics and life safety impacts on any facility that we're working on. Right. So, over the years, the code have added provisions into the building code section to specifically address how to mitigate or how to limit the damages caused by failures of non-structural components. Okay? And the main objective of these seismic provisions have always been the same. One is to prevent total loss of support. Second is preventing damage from impact components hitting each other in a seismic event. And three, which is a little bit harder to control, but we'll go over in a minute the details. Three is the design for relative displacement. What it means is, during a seismic event, things can move differently due to different natural frequencies. They can go in different directions, and we have to account for that relative displacement. We have to make sure that nothing will get drifted apart. So, preventing total loss of support. Pretty straightforward. You don't want things to fall down during a seismic event. You don't want the support to fail and break, snap, fall on people. Components on the ground, shouldn't slide over and flip over. Okay? Preventing damage from impact. Again, you don't want pipe and duct to collide with each other, causing damages to each other, to cause leak, cause health hazard. Designing for relative displacement. This is a big one, and it's part of the code. And the code, for the most part, in the later code cycles, they really emphasize they put a lot of emphasis on this, which is seismic relative displacement. As I mentioned earlier, in a seismic event, the floor could move in one direction, and the ceiling above it could move in the opposite direction. And if you're not careful, the connection at the equipment, right, can get ripped apart. And that's exactly what happened during the Northridge quake back in the 93 or 94. And you can see there the piping doesn't have any flex connectors. Okay, so at the equipment connection, it just sheared off, okay, because the floor and the ceiling above, they went in a different direction. Okay? And even the smallest piece of components, such as a fan coil, that type of relative displacement can cause a lot of damage too. In this example right here, I don't know if you can see in the back, but that right there is actually water. Right? The water flooding the hallway of the hospital, and patients have to be evacuated because of non-structural damage, right? Because the damage was caused when these small little pipes here connected to those fan coils, those soldered connections, they failed because the relative displacement were not accounted for. Okay, so a lot of those fan coils leak and cause flooding in that hospital. Even though the main building stayed in place, right? Over the years, we've learned to build stronger and taller buildings. They remain in place, but the components inside still fail because of those lack of adjustment to those items. So to handle those three key points, preventing total loss of support, basically the code require you to have positive attachment for every piece of equipment in the building. In other words, they have to be anchored down, and if they're heavy enough or if they're big enough, they will require additional bracing, to keep them in place. Right? Preventing damage from impact, again, you want everything to be anchored down so that they don't move. You add bracing so that they don't move and collide with each other. Okay? Design for relative displacement, the easiest way to handle that is just to provide flexible connection, between two components so that you can allow for that flexibility and reduce the stress on the connection points. So, with that in mind, the code writers recognize that there are small equipment, small components where you don't have to go all out when it comes to seismic bracing those items. Okay, so for example, those small little components, you can just screw it into the wall or screw it into the ceiling, and that's good enough. You don't have to provide calculations to justify it all. Right? So they set out a bunch of what we call lists of exemptions, and so they put out the requirement in the ASCE 7. Right? So based on the requirement of ASCE 7, the following items can be exempted from seismic bracing. Right? So going back a little bit, when it comes to seismic design category, every project, every facility is assigned a seismic design category, by the structural team, right? So it ranks from A all the way up to F. In California, the seismic design categories are usually D, E, and F. Okay, in California. Now, if we go further toward the East Coast, we will go down to categories C, B, and A. A, B, C, low seismic zone. Okay, so basically, the code says that if you're in those categories, basically all mechanical electrical components are exempt from seismic requirements. So that means you don't have to worry about seismic design for those components if you're in seismic design category A and B. In C, it's a little bit more, it's a little bit harsher than A and B. In C, it says that all mechanical and electrical components don't meet seismic requirements if the IP is equal to 1.0. IP, everyone knows what IP is, important factor. Ever heard of it before? Okay, I will go over that. So, if the mechanical and electrical components has an IP 1.5, then in category C, those are the only items that need to be braced. Okay, now, again, in D, E, and F, which is where we are in California, all mechanical and electrical components must meet seismic requirements. Okay, so, IP, important factor. Important factor is, by code definition, it's either 1.0 or 1.5 for non-structural components. Okay, an important factor of 1.5 is assigned to every component that is located inside an essential facility, what we call a risk category 4 facility. Okay. In other words, for example, if you're in a police station or a fire station, air traffic control tower, those are essential facilities. Everything, every component inside that facility gets an important factor of 1.5. IP 1.5. Now, if the component carry hazardous content, okay, that gets an important factor of 1.5 also. Okay. For example, if I'm talking about just a cold water line, okay, that's not hazardous content inside, right? So that cold water line can have an important factor of 1.0. Okay. Now, if I move that cold water line into a police station, now it's moved to a risk category 4 building, right? So by definition, that cold water line automatically now becomes upgraded to an important factor of 1.5. Okay, so very, very, very important to remember this. So just remember 2 things. One is from the category of the building or the structure that's in, and also the content that the component is carrying. Okay, so 1.5, and everything else has an important factor of 1.0. Now, keep in mind that some projects, the owner or the design team can choose to override these requirements. Okay, they can decide to upgrade or amplify the important factor to 1.5 for all of their components. Okay, what it does is it increases the design seismic force that we have to design for all of the components, and also the important factor plays a big role later on in the later slide on what needs to be raised and what can be exempted also. Okay.
Is that the maximum it goes to? 1.5?
Yeah, it's either 1.5 or 1. That's
Okay.
it. There's nothing in between. Okay. So these important factors, a lot of time it can be found on a structural plan. This is just an example of a structural plan right here. The structural plan can give you a lot of information when you go to the structural design parameters. Usually on the first page of a structural set, you will see this. It'll tell you the building has a seismic design category D, E, or F. Okay. So based on that, you know what needs to be raised. Okay. And then it also tells you risk category. So this one has a risk category 3. That means not everything in there has an important factor of 1.5. Right?
Luke, can I interject something really quick just to add on to this?
Yep.
Just for any of you guys that are involved in estimating or project management or anything, this part is so key when we're designing a job, when we're bidding a job for you, to always send us the structural drawing. It's always in the general notes section, so we can estimate it the right way and then we can design it the right way, because there's a big difference often at times. So I just wanted to add that little tidbit, and then this is one of the most important pieces of information we need.
Yeah, feel free to stop me anytime, guys, if you have any questions. So a lot of time the component important factor, a lot of time the structural engineer will not list that on their drawing, because they usually don't deal with non-structural components. But they'll give you the risk category, and from there you can determine on your own what the component important factor is based on the code definition. What else? Oh yes, notice you mentioned earlier the 1.5 max. There's another important factor that structural engineers like to use, which is IE. Make sure you don't get confused with IP. Right? IP is for non-structural. Okay? IE is for the main structure. Okay? We don't have to worry about that. Okay? That's for the structural engineer to design their main structure, their main building. Okay? We only care about IP. So sometimes you see IE, it doesn't mean anything for what we do with non-structural components. Okay? So this is just, I don't have to go through all the numbers here, but it just kind of show you the importance of the IP. The IP the IP plays a big role because it increases the seismic force. Okay, that's a formula in the ASCE chapter 13 that all the seismic design, seismic engineer have to design for. They give you, that's the code prescribed formula for you to come up with a design seismic force factor. So that form, according to that formula, it takes into account the location of the facility, how far it is from a known seismic zone, so a known seismic fault, how high up the structure the component is being anchored, because as you go up higher in the building, your seismic force is going to increase, okay? Because there's more swaying up on top, and also it takes into account the material types, the flexibility, and how well the component responds in a seismic event. Okay, so for example, ductile piping, steel pipe and copper pipe, they're a little more flexible compared to like cast iron piping, right? So because of that reason, when you design for cast iron piping, you got to make adjustment to your seismic force factor to increase the seismic demand. Okay, so all of those factors, they can be found in chapter 13 of ASCE. But just so that you can see right there, you see that IP is in that equation. So when we increase IP, it also increases the seismic force. Okay? Okay, so now we're going to go into see if you can see it. Can you guys see back there? Hopefully. So let's just concentrate on the latest code cycle here. Nothing has changed from the previous code. But as you can see here, we've broken this down into different types of building, different important factors. Right? Different important factors. So when it comes to seismic bracing of equipment, right? The code has certain exemptions when it comes to those equipment. If you have a commercial building with an important factor of 1.0 for the component, if the equipment weighs less than 400 pounds, less than or equal to 400 pounds, you don't have to provide seismic calculation for those. There's also a requirement of the CG of that equipment has to be less than 4 feet. Right? So you don't want a 300-pound water tank 6 feet up there and not anchor it down and not have seismic design. So that's the requirement. Anything less than 400 pounds and CG less than 4 feet, then you don't have to provide seismic calculation for it. You still have to anchor it down, right? You still have to make positive attachment to the ground. Now, if the piece of equipment is mounted on a wall or suspended in the ceiling, the cutoff is 20 pounds. Okay, so if it's 20 pounds, less than 20 pounds or less, you don't have to provide additional seismic bracing. Okay. Now, remember that just because you don't provide seismic bracing for those things, there's still a requirement earlier, as I mentioned. You still have to design for relative displacement, right? So even if you don't brace those equipment, you got to make sure that all the piping connection, all the duct connection to those equipment have to be able to withstand relative movement. Okay? It just means that you don't have the exemption is only for additional bracing. Right? You don't have to add cable bracing or kickers to keep it in place. Okay. Now, if you have equipment inline component with ductwork, we're talking about VAV boxes or terminal boxes, that are installed in line with the ductwork. That requirement goes up to 75 pounds. So again, 20 pounds of regular equipment with an inline, and the cutoff is 75 pounds. Okay. Now, if your commercial building and your component has an important factor of 1.5, remember that 400 pounds here. If it has an important factor of 1.5, that requirement comes after 20 pounds now. Okay, so the important factor plays a big role in where the exemption is cut off is. Okay, the 20 pounds for suspended and 75 pounds for inline is still in place, even though it's a 1.5 important factor. Let's see what else. You guys deal with a lot of DSA projects, schools and hospital as well.
Sometimes.
Okay. Hospital.
We do some HVAC projects.
Okay. Okay. Yeah. I mean, the requirement is the same. It all comes down to the important factor. DSA project. Most of the school has an important factor because of the risk category 3 buildings or risk category 2. So most of the components will be just ISP 1.0. For OSHPOD, hospital, the facility, the critical care facilities and all that, it automatically gets an important factor of 1.5. So you apply the important factor at the 1.5 to those facilities. Okay. Okay. Next, we are going to talk about piping. Okay. You guys see this back there?
Yeah.
Okay. Piping is a little bit more tricky. And by the way, I'll quiz you guys on these a little bit later, okay? And I'll give you prizes too. So pay attention. Let's just concentrate on first. When it comes to commercial project, okay, the commercial project with an important factor of 1.0, piping that are less than or equal to 3 inch don't need to be braced. Okay, this table is seismic exemptions. Okay, you don't need to brace anything that's listed on this table. The commercial building, right? 1.0 again, 3 inch or less. You don't need to brace it. Okay? Or it says right here, or if the piping weighs 5 pounds per linear foot or less. Okay? So even if your pipe is, whatever reason, if your pipe is 4 inch and it weighs less than 5 pounds per foot, you can exempt that too. But for 4-inch pipe, usually you don't weigh less than 5 pounds per foot. So, and then if it's a commercial project where the important factor is 1.5, right? So for example, again, it's a risk category 4 building, let's say. You have to brace everything down to 1 inch. See? So the only exemption is 1 inch or less now. If it's an important factor of 1.5. So you can see the big jump there as far as bracing requirements. Okay? 1 inch or less, important factor of 1.5 can be exempted. Right. Any questions so far? Okay. Now, moving on to DSA project. Again, going down to DSA project. If it's ISP 1.0, those requirements are still the same. 5 pounds per linear foot or 3 inch diameter. Those can be exempted from bracing. Okay. Now, one thing to note though, going down to OSHPOD facility, or even DSA facility for that matter. Notice that for ISP 1.5, the requirement is a lot different than a commercial building with an important factor of 1.5. See, commercial building, the cutoff is 1 inch, right? For OSHPOD hospital and DSA project where ISP 1.5, they're using the same weight and size exemptions as a commercial project. That's a big deal. In fact, as a matter of fact, it means that it's less stringent than, let's say, a police station. Okay? Back in the day, back in the older code, that's not the case. Back in the older code, for our OSHPOD project 1.5, they follow the same commercial building 1.5. But the newer code cycle, that changed. So that works in our favor, actually. So we have less pipes to brace. Okay? Now, there's a note in here. I mentioned earlier some project, the design team or the owner can choose to override the code and increase the important factor. If you run into those projects, make sure that you get confirmation from the team that they have to be aware that when they increase the important factor, it will affect the bracing requirements. Okay, so you have to ask them, oh, you really want to, what do you want us to do? You just increase the force with an important factor of 1.5, or do we need to follow, pipe bracing exemptions of the important factor of 1.5? Okay. Any question before I move on? All right. This one is, you guys do a lot of electrical? Any electrical conduits or anything? Okay. So
No plumbing either, Luke.
So I can skip electrical.
Yes.
Yes. Okay. Ductwork. Ductwork is a little more simple. Right? Ductwork, regardless of important factor, the cutoff for seismic exemption is HVAC ductwork cross-section area less than 6 square feet and 20 pounds per linear foot. So if you have a 36 by 24 HVAC ductwork, that's 6 square feet, right? So 6 square feet, that's where you have to start bracing. But if it's less than 36 by 24, you can exempt it, right? So 6 square feet, less than 6 square feet, and 20 pounds per linear foot. Okay. Now, the only exception is if the duct contains hazardous content. Okay. So if the duct is, transferring, generator exhaust or dangerous chemical fumes or whatever, all of those ducts have to be braced, okay, regardless of size and weight. Okay. Pretty straightforward, right? ISO P1 and 1.5, same requirement for ductwork. So ductwork is a little more straightforward. Let's see.
Did you say, Luke, that there hasn't been much changes from 2022 to 2025?
Yeah, all these bracing exemptions are the same since 2019
Oh, okay.
to 2025 California Road. I don't know if you guys are familiar with the 12-inch exemption, but basically in the old code cycle, they said that if the component is utility is suspended, within 12 inches of the structure, it doesn't need to be braced. Right now, under the new code cycle, that exemption has pretty much gone away. Well, it hasn't gone away completely, but it became more difficult to follow or to apply. For example, based on this new code cycle here, the 12-inch rule for a trapeze system. Okay, if the rod is 3/8 inch and it's no longer than 12 inches, and the trapeze is 100 pounds or less, it can be exempted. Okay, and if the rod is 1/2 inch, the weight goes up to 200 pounds, and if the length goes up to 24 inches, that weight comes down to 100 pounds. But notice that this only applies when the important factor is 1.0 only, and you have to maintain the pipe size exemption previously. Okay, in other words, if any of these pipes require bracing per the previous exemption or the previous requirements, then you can't apply the 12-inch rule. Right? So, again, this only applies to important factor of 1.0. Any of these pipes has an important factor of 1.5. This 12-inch rule doesn't apply. So as you can see, it becomes very hard to apply on any project because by the time you apply this 12-inch rule, you pretty much just apply it to the pipes that don't need to be braced to begin with. Okay. Okay. Individual pipe, 12-inch rule for individually hung pipe. If you use it only applies to piping with 3/8 or 1/2 inch rod, and the weight of the pipe at that location is no more than 50 pounds. So the intent of the 12-inch rule in the code is just to make sure that it only applies to very small pipes or components that don't weigh a whole lot. For ductwork is pretty much the same. It only apply if the ductwork has an important factor of 1.0. Whole inch, 100 pounds, half-inch rod, it goes up to 200 pounds. And so forth. Electrical, we're not doing the electricals, we're going to skip that. Okay. So this is I showed you an earlier photo of the failure at the connection of the piping to the coil, right? So this is one way where they address the relative displacement, okay? Adding a flexible connector here, right? So that way there's a lot of movement that can be had between the component and the associated piping. Okay, so this is another solution, picture solution for piping overhead into the equipment. You see these braided hoses. They allow for a little flexibility. So that takes away the stress on the, take away the nozzle on the connection. Also, I'm showing a picture of a different type of instead of a braided hose connection here. This is one of those rubber bellows or neutron bellows. They allow a lot more flexibility. They can compress and they can rotate a lot more than the steel braided hoses. Okay. Okay. This one is I added these photos here just kind of show you what we don't recommend. Okay. You notice here these are so-called flexible fit couplings, right? You guys are familiar with these. Our contractors like to use those to address relative displacement. You can see that they're stacking, 3 or 4 of them at each joint, thinking that they can take some movement, but in reality they're very stiff. Okay, this piece of equipment right here, this chiller, it's sitting on spring isolators. So during a seismic event, especially when the equipment's mounted on spring isolator, they move a lot, okay, due to the presence of the isolators. So these, I don't want to say rigid, but they are rigid. These flexible couplings, they prevent that type of movement. So they still induce a lot of stress on the pipe connection into the equipment. So in this particular job, these couplers were specified, so the contractor just used them. But if we can make a recommendation, we would recommend people to stay away from those rigid or flexible couplings. This one right here, you kind of see here they have these rubber bellows. They're pretty effective. They're a lot more flexible than those ones. So they allow for flexibility in the pipe connection. But in this case, I think what happened is that somebody forgot to design support for the pipe elbow here, so they tie that back to the base. Right? So you can see that there's a flexible connector there, so that one locks it up, right? So that defeats the purpose. And of course, on this side right here, this one right here, this has nothing, right? And there's no flexible connectors there. So it's going to have the same type of failure that you saw in the earlier photo. So this is just an illustration of how to handle relative displacement for big equipment. Okay. So this one right here, solid equipment attachment, just that photo, the previous photo. There's nothing between the piping and the equipment, right? So just solid pipe. So when the building moves, that pipe's going to try to bend, but the pipe's too stiff, right? So it's going to put all that moment at that connection. So that's going to rip that connection. Okay. So this one's a little bit better. This one, it has a spherical expansion joint or those rubber bellows. Okay, this allows for it to take that moment, right? So it absorbs all that rotation there at that joint. And here's the braided hose, the flexible braided hose. Now, the only problem with the braided hose is that it only flexes in one direction, right? And when it flexes in one direction, when it flexes, it shortens, right? And when it's shortened, it's going to pull down on the pipe header on the top. So if you use this type of flexible braided hose, consider the drop in the header pipe above. So you probably want to put like a spring hanger or something up on top to allow for that dip in the pipe elevation.
Also, Mason makes both of those options, just so you guys know. The braided or the rubber.
Oh yeah, yeah. I mean, this one also has the rubber ones are very effective in acoustical isolation as well. They reduce the noise transmission from the equipment into the pipe. Yeah, this is a photo of installation of cooling tower with spring isolators, and of course these are the bellow, the rubber bellow that I mentioned. Okay, quiz time. I mentioned earlier. Let's see how well you guys remember. Oh,
Everybody just woke up.
You'll let me forget after.
You can choose, right? If you get it right.
Chad's gonna steal it.
I need to get rid of all these so I don't have to carry them back. Oh, they're the same. 3 for every question. No. Let's just do a warm up first. That's it. Okay. Let's do a warm up question. So let's say if I have a commercial building. All right, commercial building. The question is bracing required for this trapeze under the current California building code? What do you think?
What's the importance of it? What's the importance of it? I would say 1.5. No.
I think you need bracing for the condenser water pipe.
Commercial building. Remember, commercial building. Okay. Risk. I'll give you a hint. Commercial building, risk category 3. Okay.
Oh.
I think.
It's under the
It's all
5
under
pounds per
3.
foot.
Because that one's already bigger than 1 inch.
I think. It's only 12.5.
Wow, looks like I'm gonna bring all these home.
Oh.
No, let's walk through slowly here. Okay. So risk category 3, commercial building. What was the requirement? Okay, you know the ISP from there, right? ISP based on the building structure, risk category 3, ISP is 1.0, right? Now, is any of these pipe carrying anything hazardous? Okay. Cold water line, right? Not non-hazardous. Okay. So does that get what important factor does it have? 1.0 still, right? Okay. Medical air. Actually, I need to give you guys some more hints. All of these gases, oxygen, nitrogen, for what we do, they're considered hazardous. Okay, nitrogen, oxygen. Okay, air is not hazardous. Okay, air is not harmful. Okay, but if any of these gases they leak, they're hazardous. So, by definition, these can have an important factor of 1.5. Okay, medical air, you can reason that it's non-hazardous. It's just clean air. Right? So, but again, if you took note, there was an exemption based on size, right? When it comes to piping with important factor of 1.5. Anyone remember what it was? What size is exempted for 1.5? 1 inch or less, right? So this one's 3/4 doesn't need to be braced, right? Even though it's 1.5. This one 3/4 doesn't need to be braced. This one 1 inch, we already said that it's medical air, it's clean air, so it's important factor is 1.0, right? And this one, 1.25, cold water, you know, nothing hazardous. So based on that, none of these pipes need to be braced, right? But remember, there was a, I forgot, did I forget the trapeze?
I think we did. I thought we talked about that.
Trapeze? Okay, sorry. If pipes are on trapeze, the weight, the brace exemption is 5 pounds or less. Okay, so 5 pounds per linear foot. So if the trapeze is 5 pounds per linear foot or less, it can be exempted. Okay, but you still have to keep the size exemption. Okay, so this one, the whole trapeze weight 4.5 pounds. So requirement of trapeze bracing is not met, right? So this whole thing doesn't need to be braced. Okay. All right, now we're going for the real thing, right?
The lightning round.
All right, let's get this one.
That's a yes.
Raise your hand if you know the answer.
Bracing.
Bracing? Yes. Why is that, sir?
6 pounds per linear foot.
That's correct. So please come up, pick your prize. Easy, right? Easy money.
See what we got.
Top day, hot cake.
I'll take a red.
All right.
Thank you.
Okay. This one. Remember, we're still in a commercial building.
That's no bracing.
Yes.
Raise your hand.
I think it requires bracing.
Yep. And why is that?
The 1 1/4 inch gas, if it's considered hazardous,
Yes.
exceptions.
Very good.
Controls guys are winning.
You know, if you know these, you pretty much know 80% of seismic bracing requirement in California.
Don't brace it with the gas on.
Okay, so let's go to. Yeah, that's just the answer, right? No. Hey, don't get too excited now. Okay, now we're moving to a risk category 4 building, right? Commercial critical risk category 4 building. Same thing, same question. Is bracing required for the current code? Let's go with this one. Raise your hand if you know the answer. Yes, sir.
Yes, bracing is required because for category 4 would be IP 1.5, so you just can't have anything over 1 inch
Okay.
for a commercial building. That's it.
Okay.
And it's also the 5
Yes.
pounds per foot,
Yeah.
which would make it not
Exactly.
work under other building category types.
Everyone heard that? So it meets two requirements here. It's over 5 pounds per linear foot, right? And also because it's a commercial building, risk category 4 building, you know, all these pipes gonna be having a ISP 1.5. So, and this one is greater than 1 inch. That needs to be braced because it's on this trapeze. That whole trapeze needs to be braced. Okay. All right. Go on to this one. This one. Same. We're still in the same building, okay? Risk category 4 building. Come on.
I would say yes.
Yes?
Yes.
But why is that?
Because it's a category 4.
And
Then, well, I know that pipe right there is bigger than 1 inch.
this one?
Yeah, and it's hazardous.
That's correct. You're absolutely correct. Okay. So, two things here. Risk category 4, again, you know, this pipe right here has ISP 1.5 based on 2 requirements, right? It carries hazardous content, so 1.5, and it's in the risk category 4 building, so that makes it 1.5 also, right? So because of that needs to be braced. Okay? All right, last one on this. This one right here. Risk category 4 building.
Gotta wait one.
The annex is killing you.
Look at it.
But yes, it requires bracing because the cold water's over it.
Oh, because
Cold
it's
water.
Category 3.
Cold water is
This
greater
is
than.
category 3.
This is category 4, right?
Category 4.
Yeah, so it's over 1.
Okay, so that's correct. So
Okay.
it gets an important factor of 1.5, and because of that, it needs to be raised. Right? So, see how many more do we have? We have 3 more, 2 more, right? I'm trying to throw you off. Okay, so let's move to a risk category 4 hospital now. Okay, now little hint. I told you earlier. I don't know if you guys remember. But I'm not going to remind you what that hint was. But remember, this is a hospital, HCI Oshkosh Hospital. Risk category 4 by default is bracing required for this guy. Yes.
I guess because the cold water line's over an inch still in category 4.
No.
Okay.
Anyone else? No, just kidding. No. That's it. So I mentioned earlier, HCI Hospital. It's actually less stringent than a regular commercial 1.5 project. They actually went and they make an exception. They said, okay, 5 pounds per foot. So this thing, since it's not carrying anything hazardous, OSHPOD actually says, okay, it's okay. You don't have to treat it like that. Okay? Sorry. Very close. You're almost there. 50-50. Okay, this one. Raise your hand. Oh.
Yes,
Okay, you're first.
this time.
Yes.
Oh.
Yes, that's correct. All right, so this one has this. You see the difference?
Yes.
But that's because, like I mentioned earlier, HCI, in fact, they went and they reduced the requirement. Okay? Now, if this is in a police station or a firehouse, then your previous answer would be yes.
Got it. So the first one was a hospital. I didn't realize that. I thought we
Yeah,
were
the other one was
just-
commercial risk category 4 building. Okay, last one. Don't make me take this home now. Does this need to be braced? Let's see. How many of you haven't had yours yet?
Same building?
Yes, it's a hospital risk category 4 building. I saw a hand raised. Oh, he put it down. Okay, you go ahead.
Yes, based because of the fix.
I'm sorry?
Yeah, because of the 6 pound.
6 pounds per foot? That's correct. That's correct. Pass that down. This is just basically I don't know if I want to go through all these details because these when it comes to seismic bracing layout and all that, it takes another hour just to go through all those details. But basically, this typically how when you guys send us drawings to review for seismic bracing, this is what we typically do. We review, we take into account the layout of every single pipe or every single duct, and we'll go in and we put in seismic braces where they need. Well, we first have to determine if they need to be braced, right? And then if they do need to be braced, then we'll have to locate the braces so that they're in the correct spot. And also we have to take into account the structural limitation. If there's any load limitation, we have to take that into account, and we have to make sure that the braces don't overload the structure. Right? And also we have to make sure that if the hanger of the the piping and the ductwork, can handle the additional seismic load. So all that has to be considered. With that, I think I am done for this presentation. Do you guys have any more questions?
Are you guys all the ones responsible for creating the shop drawings that will make its way to us someday?
That's primarily us two, how it was in here.
Okay, okay,
But
Yeah.
all right.
Yeah. So, do you guys actually have the model in the seismic braces, or is that usually
sometimes,
default?
so it depends on the job. We have, I think, more increasingly had jobs where we need to model in the hangers and supports and then the seismic as well. So it's becoming, I think, a little bit more common as people are just
Yeah.
wanting us to dim everything
Mhm.
information.
But you need to know where to put those braces, right? Or do you just
Yeah, so we'll have to go
Yeah. Okay.
contact someone.
Yeah. So a lot of time I think what we typically do is we take the 2D layout and we just kind of mark it for you guys, and then we just tell you guys, okay, we can go and model these in. If it doesn't fit or it doesn't work in that location, then we'll revise and we'll do something else. We'll go somewhere else, right? So I mean, we do have all of those seismic bracing models, all those dynamic blocks and that can be used to do Revit and so forth. With that, you guys have been wonderful. Thank you for this opportunity. Yeah.
Thank you.
Thank you.
In Chad's office, right?